So last time we were at this, the shot putter problem, and we were rudely interrupted by the bell. So I guess we're going to have to work this thing out and finish it up. Okay, so most of you, I hope, tried this and finished it. And if you didn't attempt it, it's a good idea you do it. It's always nice to suffer through it first before I do it. All right, so here we go. VIY is equal to simply V naught, V naught sine theta naught. So if you plug in these values, my VIY then is equal to V naught is 14 sine of 40 degrees. Okay? So if you work this out properly, I think you'll get something like 9.0 meters per second. Okay, and this, y-hat direction. So I'm going to just put that in there just to see. And for VIX, VIX is really nothing more than V naught cosine theta naught, right? So if you work that out, your VIX is equal to 14 times cosine of 40 degrees. And that should come out to something like 10.7 meters per second, I guess, x hat. All right. So it's a good idea to know these so that you can actually work it out. Always have this ready before you start the problem. Then it asks, calculate the horizontal distance traveled by the shot if it leaves the athlete's hand at the height of 2.2 meters above the ground. So your y initial is 2.2 above the ground. Your y final is 0. Okay? And it'd be nice to find time, right? So find time first. Okay? It's always a good idea to find time first. And since this delta y is not 0, it's not a good idea to use the range equation. We really should not use that. Okay? So to find time, let's use the y direction. Okay, let's use the y direction. Let's write down everything we know in y. Here, we know y initial is equal to 2.2 meters. We know our y final is equal to 0 meters. We know our y, VIY, initial velocity in y, is 9.0 meters per second. We also know a sub y, which is negative 9.8 meters per second squared. So from this, it looks like we can use the second equation, right? Y final is equal to y initial plus VIY t plus 1/2 a sub y t squared. So if we put all the values in here, I get y final, 0. Y initial, 2.2. Initial velocity in y is plus 9 t, right? And then we have plus 1/2 negative 9.8 times time squared. So if you work this thing out, right, it looks like we can use quadratic formula for this. Okay, so let's take a look how we can use this. I guess 0 is equal to, then you could say, 4.9 negative 4.9 t squared plus 9.0 t plus 2.2 is equal to 0. So my A is equal to negative 4.9. B is equal to 9.0. C is equal to 2.2. Okay? And if you use quadratic formula, let's take a look. So 4.9, and then 9.0, and I get something like, what do you get? I get 2.0, so time t is equal to 2.055 seconds, okay? Or time t is equal to negative 0.218 for 5 seconds. So obviously we're going to pick the positive time. Okay, we're going to pick the positive time. Once we know the time, now we can use that time for the x. So we know x initial is 0. We also know we're looking for x final, basically. We know VIX, which is 10.7 meters per second. We know a sub x is equal to 0, because acceleration in the x direction is 0. And we know time now, and time happens to be 2.0552 seconds. So we can use second equation, x final is equal to x initial plus VIXT plus 1 half a sub xt squared. Now you know a sub x is 0, so this whole term is going to go to 0 right here. Your x final is what you're looking for, is equal to 0 plus 10.7 times 2.0552. So what is your x final? X final is equal to, well, let's use that, 10.7 times 2.0552, and I get something like 21.99 meters as my x final. So the distance it travels, your delta x, is equal to like 22 meters. Okay? All right. Any questions? I'm going to go with your pace, Ava. So you let me know when you're ready to move on. Are you ready to go on? All right. Let's take a look at the second problem. Actually, problem number 6. Um, a hunter aims directly at a target. So obviously, this hunter does not know the physics behind all this, right? So if the hunter aims directly at the target, so here, if this is the target right here, that's the bullseye. And if there were no gravity, it'll hit it right on the bullseye, aim directly at it, right? Well, initial velocity, the V naught, happens to be 250 meters per second. But learning physics, that bullet's not going to travel straight across because gravitational pull of the Earth. So the bullet actually is going to travel like this and hit the ground, hit somewhere below the target because of because of gravitational pull. So they want you to figure out how much will the hunter miss the target by. Okay, so we're going to consider here y initial. Let's call that, I don't know. Where do you want to make your zero? You want to make your zero here, or you want to make your zero here? It shouldn't matter, because if you make your zero here, your delta y is most likely going to come out to be negative value because it's going down. But if you make your zero here, your delta will come out to be positive. So at the target, you make it zero there. All right, I think that's logical. So initial position, we're going to make that zero. And we're going to make this position right here, y final. We don't know what that y final position is. We do know, however, that delta x, okay, so here, if we were to look at this, your delta x happens to be so the delta x, the target is 240 meters away. So in this particular case, since they give us the V naught, which happens to be same as your VIX because it is aimed directly at a target on the same level. So your V naught is your VIX, and obviously your VIY is 0 because it is aimed directly at the target. So we could probably use the x direction to find time, right? So find time using x direction because we don't know the height. Right? So here, let's write down everything we know. We know x initial 0, x final is 250 meters. No, I'm sorry, 240 meters. 240 meters. We also know VIX, which is same as V naught, which is 250 meters per second. We also know a sub x. You know the acceleration in the x is always going to be 0. So I'm looking for time here. So to find time, I think we can use the x final is equal to x initial plus VIXT plus 1/2 a sub xt squared. We all know a sub x is 0, so the whole term drops out to 0. Your x final, 240. Your x initial, 0. Your VIX is 250, right? And your time is what you're looking for, plus 0, I guess. So your time is equal to 240 divided by 250, which comes out to 0.96 seconds. So it's going to take less than a second to travel horizontally 240 meters. Now that we know that time, I want to see how much that bullet will be affected vertically by gravitational pull. So, but by the time it takes less than a second to move 240 meters horizontally, it's going to fall for 9.96 seconds, right? So let's see how much it falls in this time duration. So we can say then, right, y final is equal to y initial plus VIYT plus 1/2 a sub yt squared. We already know, we said y initial is 0. We said y final, we don't know. We know a sub y is equal to negative 9.8 meters per second squared. And v sub iy is 0 because it was shot horizontally. And we know time is 0.96 seconds. So we can plug all these values in here. So since we're looking for y final is equal to your y initial, 0. Your VIY is also 0, plus 1/2 times negative 9.8 times 0.96 squared. Okay. So if you solve for y final, you should get negative 4.52 meters. And that makes sense because it fell in the negative direction 4.52 meters. That's like 15 feet, right? Or not 15, maybe like 14 feet. That's a lot. If, you're missing by a lot, right? You're missing by like a whole story and a half, like almost 2 stories. All right. So you're gonna miss the target ridiculously bad. So in order to shoot that target, what you need to do is you need to aim it slightly above. And when I say slightly, I mean slightly above, so that it travels parabolic path like this. Well, let's see what angle you have to shoot that thing. Okay? And you'd be surprised how small that angle is. I mean, like you'll be like, oh my God, that's all it is. Right? So instead of shooting it directly across, now we're going to aim this thing. Now we're going to aim this thing slightly above. I'm going to exaggerate this, obviously, so you guys can see it better. I'm going to aim this thing at an angle theta naught. And we don't know what that theta naught is. But our muzzle velocity will still be 250 meters per second. So what's going to happen is, instead of going straight down like that, now it will travel in a parabolic path and hit a target at the other side, where here is the bullseye. I don't like shooting animals, so I'm going to make bullseye. Like so. We know the range is still 240 meters, right? The range is still 240 meters, which means since we know our initial position in y is 0, and our final position in y is also 0. So our delta y is equal to 0. And if that's the case, we can use our range equation, right? So and the range equation is, right, delta x is equal to, right, V naught squared times sine of 2 theta naught whole thing over negative G. That's the range equation. So if we use this equation here, we know V naught, we know delta x, we know G, we can definitely solve for theta. Okay? So using this equation, and if we solve for sine of 2 theta, I multiply both sides by negative G, right? Then I get negative G delta x. Divide that by V naught squared is equal to sine of 2 theta. Now I'm going to solve for 2 theta. So 2 theta naught is equal to sine inverse of negative G times delta x over V naught squared. So let's plug in this value and solve for 2 theta naught. That is sine inverse of negative 9.8, which is going to be positive, times delta x, which is 240, over 250 squared. So if you work that out, here's what you get. You get, let's see, 9.8 times 240, and you divide that by 250 squared, and I get something very small. So I get 2 theta naught is equal to sine inverse of, this whole thing inside here is 0.037632. So what is 2 theta? 2 theta is equal to sine inverse of this mess right here, 0.037632, right? Which is the answer. That gives me 2.15666. Oh, 666. Bad omen. So I get 2.15664 degrees. So theta naught is equal to half of that. So you divide both sides by 2. So if you divide that by 2, and that is 1.08 degrees. Holy shnikes. That is so friggin' small. So if you aim your gun, like literally, like just 1 degree above, you could hit that target. Or if you're less than a degree, then you're gonna miss it by like 14 feet. So hunting is tough. You know? If you know your physics, though, it's easy. I don't like hunting. I mean, I could understand if you're gonna eat the meat, then you can hunt, because if you're gonna eat the meat and if you're gonna do it for survival, I understand that completely. But just to show off or kill for fun, I don't agree with it. Just take a camera and shoot it with camera. I think that's wonderful. That you could always share it with your friends. And look what I caught with my camera. Ah, that's just me. I mean, what did that animal ever do to you? All right, here we go.
Mr. Kim?
Yes?
Sorry, I had a question about the 6 problem.
Yes.
So, like, over there, you said that y final equals 0, but we found the value to be negative 4.52.
This right here?
Yes.
This is if you are aiming the gun at 0 degrees. The bullet's
Oh,
going to
okay.
fall down 4.52 meters. But if you aim the gun at 1.0 degrees, right, this way, it will end up at the exact same level at 0 height.
Oh, okay. Got it. Thank you.
Okay?
Yep.
Any other questions? All right. Two more. Right? Two more. So I will post these on Schoology. Like remember, did you see the PDF I posted up? Yeah. So I'll do that too, so you guys can have it up there. All right. Let's take a look at page 8, number 7. I like this problem. I wonder why. Ava, why do I like this problem, Ava? Ah, you're brilliant. All right, a projectile is fired with an initial speed of 75.2 meters per second at an angle of 34.5 degrees above the horizontal on a long, flat firing range. So, flat firing range means that we have delta y is equal to 0. That's what that means. All right. So let's visualize this. Let's visualize this. So we're going to actually fire this thing at a flat firing range, like so. And we're going to fire this thing at an angle of 34.5 degrees. Again, I'm just estimating these. And this V naught is equal to 75.2 meters per second. The angle, theta naught, is equal to 34.5 degrees. So what's going to happen? Well, this thing's going to go in a parabolic path, and it's going to land on the other side of the range at 0 height. So you could say your initial position in y is 0, your final position in y is 0. Your initial position in x initial is 0, your initial position, your final position in x, we don't know. Right? So we know this so far. So before I even start doing part A, B, C, D, I'm going to actually try to do breaking this up, V naught into VIX and VIY first. That's the first step that I should always do. Okay. So here, I would like to redraw my V naught a little bit bigger so we can see. All right, so here's my V naught. Right? And then I have my VIX and VIY. Okay, so here's my VIX. And here's my VIY. And my VIY is equal to, again, V naught sine theta naught. And this is my theta naught. And my V naught is 75.2 meters per second. So my VIY is 75.2 sine of 34.5 degrees. And when you work that out, what do you get? VIY. I believe you get something like 42.6 let's see, 75.2 sine of 34.5. Yeah, 42.6 meters per second. Y hat. Okay, that's good to know. So we have that. Then Vix is equal to V naught cosine theta naught. And if you work that out, I think you get something like 75.2 cosine of 34.5 degrees, right? And if you work that out, your Vix is equal to, let's see, 75.2 cosine of 34.5, 61.97 or 62.0. Okay, so 62.0 meters per second. X hat is Vix. So that's also good to know. All right. Now we can start this problem. Okay, most likely they're going to ask us to find time probably, but so here, part A, determine the maximum height reached by the projectile. Wow. Maximum height reached by projectile is right here. At this point, we know a few things. We know acceleration due to gravity is going to be in the y direction only at negative 9.8 meters per second squared. We also know the velocity in the y direction at maximum height is 0. Correct. So my velocity final in y max is 0. That's very important. So we can actually see that it's going to only possess the Vx only. That's the only thing that's going to possess at that moment, at maximum height. So for part A, find y max. And at y max, you know Vy max is 0. We still have acceleration in y though. That is negative 9.8 meters per second squared. We also know, right, that initial velocity in y happens to be 42.6 meters per second. And I'm looking for my delta y, which is the y max, right? So looks like I don't have time here. If I don't have time, I should go for equation number 3. And equation number 3 states Vfy squared is equal to Viy squared plus 2 a sub y delta y. That's equation number 3. Therefore, we know your final velocity at y max is going to be 0. You square that, you still get 0. Your initial velocity in y is 42.6, and that's got to be squared. Plus 2 times negative 9.8 times delta y is what we have. So if you solve for delta y, you solve for delta y, you get this, square it, and you bring it to the other side, you get negative of that. So what is that? So you get 42.6 squared, and then you get negative, right, 1814.76. Divide that by negative 19.6. And then your delta y comes out to 92.6 meters. So that's the highest it's going to go. So y max is equal to 92.6 meters. And that is from the ground. That's only from this location, the height where it was shot from. Now think about if this were shot from like high above the cliff, then you want to add that height of the cliff to that to get that maximum height, right? From the ground. So we'll talk about that on the next problem. All right, Dan, what about part B? Part B asks the total time in the air. Oh, okay. Well, I think that's pretty easy. Right? Find T total. Okay. So it's basically starting from 0 and the height of 0 and end up at height of 0. So my y initial is equal to 0. My y final is equal to 0. Right? For the total time. Right? And then my initial velocity in y is equal to 42.6 meters per second. I know a sub y is equal to negative 9.8 meters per second squared. And I'm looking for time. Now this time is total time because it starts here and ends here. So that is the total time. If I were to find like time for here to here, it'd be different. Or time from here to here, another thing, right? Therefore, this is my total time. Looks like I have all the ingredients for equation number 2. So here I have my y final is equal to y initial plus VIYT plus 1/2 a sub y t squared. Let's plug in everything we know. Okay, we know VFY 0, VIY 0 plus 42.6 t plus 1/2 negative 9.8 times t squared. So I get 0 is equal to, right? I'm going to factor out a t here. So t times 42.6 minus 4.9 t. So my t is equal to either 0 or 42.6 divided by 4.9, right? And I get 8.69 seconds. So that looks like a pretty decent time right there. And it makes sense because your position is 0 at time t is equal to 0. And 8.69 later is going to be at 0 position as well for the y. All right, that was good. That was good. What about C? The total horizontal distance covered. That is the range, right? Well, there's so many ways to do that. One way would be, since you know your delta y 0, you could use it, you could use your range equation. You could have done that if you wanted to. Another way is, since we know time now, we can write down, we're looking for x final, right? We know x initial is 0. We know a sub x is 0. We know the Vix is equal to 62.0 meters per second. And most importantly, we have time. And this time for the total travel is 8.69 seconds. So we could probably use our equation number 2 again, which is x final is equal to x initial plus Vix plus 1 half a sub x t squared. A sub x, 0. So x final is equal to x initial, 0. Vix, 62.0 times time, 8.69 plus 0. So our x final is equal to, I get something like 539.0 meters. I used the unrounded number to calculate that, I think. Or if you want to use, alternative way is, you could use delta x is equal to v naught squared sine of 2 theta naught over negative g. You could use that, you know. And if you use that, you're going to get 75.2 squared times sine of 2 times the theta, right? So that is that's like 2 times 34.5, and that will be 69 degrees.
One student.
Hey, that's all I need. Huh?
She gets all your attention.
Yeah, she's awesome. She helps me with the pace, actually.
Good. What are you doing?
We're doing projectile motion.
Projectile motion. Yep. Okay. Good stuff. Got a good one.
Yep. Divide that by negative of negative 9.8. Right? Negative of negative 9.8. And guess what? If you work this out, I guarantee you probably get the same thing. So let's try it. Let's try it so we could all be a scientist here. So 75.2 square that times sine of 69 degrees, right? Divide that by negative of negative will be positive 9.8. Holy shnikes, that's pretty close, right? 578.7, 579, right? So no, 538, sorry, not 570, 530. All right, so it does work. It does work. Okay. All right. Now comes something strange because now they're asking the velocity of projectile at 1.5 seconds after firing. Well, let's analyze this. 1.5 seconds, would it be on the way up or on the way down? On the way up. And how did you logically got that answer?
If it goes around the 9 seconds, but still before, that's less than halfway.
Absolutely. So Ava's logic was, hey, this is like 8.69 seconds. So halfway point should be around like 4, a little more than 4, but 1.5 should be somewhere around here somewhere. And that logic is absolutely correct. Beautiful. So for part D, if we want to visualize that, this thing is still on the way up, and my projectile will be here somewhere, and this would be the final velocity going like this. This will be the V final at 1.5 seconds, right? And we don't know what that is. However, we do know one thing. We know the x final at any time, this x final VFX at any time is equal to 62.0 meters per second. Because that doesn't change no matter what time it is. So that's something we know. However, we don't know what the VFY is at 1.5 seconds. So VFY at 1.5 seconds, we don't know. So now we can say, oh, then we could figure this VFY out. So let's write down everything we know for VFY, or in the y direction. We know initial velocity in y happens to be 42.6 meters per second. We also know that acceleration in the y direction is negative 9.8 meters per second squared. We know one more thing. We know time is equal to 1.5 seconds. And we're looking for VFY at 1.5 seconds. So we could probably use equation number one. Our equation number one states VFY is equal to VIY plus A sub y times time. Okay? So here, my VFY is equal to my VIY, 42.6, minus 9.8 times 1.5. So if we calculate for VFY, my VFY comes out to, let's see, right, 42.6 minus 9.8 times 1.5, and I get 27.9 meters per second. And it's positive. It's positive. That means it's still on the way up. It's still on the way up. So I know my VFY and I know my VFX. Therefore, my VF at 1.5 seconds is equal to, right, 62.0 x hat plus, right, plus 27.9 y hat meters per second. Now, if I want this in magnitude and direction form, all you have to do is find the magnitude of that using Pythagorean theorem, which is square root of 62.0 squared plus 27.9 squared. And if you work that out, I think you'll get something like 67.99 meters per second. Or simply 68 meters per second. Then, to find this angle theta at 1.5 seconds, your theta at 1.5 seconds is equal to tan inverse of VFY over VFX. Okay? So VFY over VFX. And that is equal to tan inverse of VFY is 27.9, VFX 62.0, and that comes out to 24.2 degrees. So this is the Cartesian form of, right? The Cartesian form of your final velocity. And your polar form is equal to 68.0 meters per second, comma, theta of 1.5 is equal to 24, oh, look at that, 24.2 degrees. This would be your magnitude and direction form. Cool? All right. Any questions from the cyber world? By the way, that was Dr. Meisinger who just walked in and checked in on us. And she was very impressed with how many students I had in my class. All right. So that was page 8, number 7. Good problem. Good problem. Good problem. All right. Next, we need to now combine, right? Shooting something from at an angle from high atop of a cliff, where my delta y is not 0 anymore. Okay. So now let's take a look. This is our last problem. A projectile is fired from the edge of a cliff 125 meters above the ground level with the initial speed of 105 meters per second. So we know my V naught is 105. My Y initial happens to be 125 meters. And my Y final is equal to 0. Okay? So the angle, the launch angle is 37.0 degrees. Now, determine the time it takes for projectile to reach point P, which is right before it hits the ground. So before we even start doing that, we should find my x and y component of my velocity, okay? So let's draw out my V naught. Let's draw out my V naught here. My V naught is equal to 105 meters per second, which will have x and y components of that. And here I have my VIX and my VIY. And my VIY. And my launch angle of 37 degrees. So my VIX is equal to, obviously, V naught cosine theta naught. Therefore, my VIX is equal to, okay, V naught, which is 105, times cosine of 37 degrees. So when you work that out, your VIX comes out to, I guess it's like 3, 4, 5 triangle. So 88, no, 84. Let me see. So here, 105 times cosine of 37. Yeah, 84. So 83.9. 83.9, right? So 83.9 meters per second, x hat. Then your VIY is equal to V naught sine theta naught, and that is equal to 105 times sine of 37 degrees that is like what? 30, 60 something, like 66 or something. So let's take a look. So 105 times sine of 37. No, 63, right? 63. So 63.2 meters per second. All right. So that's my V I Y hat. So here we have two components here, VIX and VIY, and those are very important to have. All right. So part A, they're asking, all right, how much time does it take, right? So for part A, find T total. So for that, it might not be a bad idea to use the Y direction again, right? So use Y direction. And let's list everything we know in the Y direction. We know Y initial is equal to 125. Y final for at point P is 0. Right? At point P right here, Y final is 0. So 0 meters. We know V sub IY, we calculated to be 63.2 meters per second. We also know A sub Y is negative 9.8 meters per second squared. And I'm looking for time. The time at point P is the total time in the air, basically. So if we use equation number 2, right, equation number 2 states y final is equal to y initial plus v I y t plus 1/2 a sub y t squared. So here, 0 is equal to 125 plus 63.2 t, right, minus 4.9 t squared. Where did I get that negative 4.9 from? Excellent. That's 1/2 of negative 9.8. So this looks like a quadratic equation where my A is equal to negative 4.9, my B is equal to 63.2, my C is equal to 125. So if I take out my calculator, or since I don't have quadratic formula in my calculator, what I did was I used this thing right here, and then I got 4.9, and then here that's 63.2, and then here let's do 125, and then calculate, and it looks like I got two answers. My time is equal to either 14.64 seconds or negative 1.74 seconds. Obviously, we're gonna pick 14.64 seconds, but negative time doesn't work out, right? So we're gonna pick the positive time of 14.64 seconds as the total time. So my T total, okay, is equal to 14.64 seconds. What about part B? Determine the range, x. So for part B, they want us to find delta x. So let's list everything we know. So x initial, we know it is 0. We're looking for x final, so put question mark next to it. We know Vix is equal to 83.9 meters per second. We also know a sub x, which is 0. We know time, we just calculated to be 14.64 seconds. So it looks like we can use the second equation again. So x final is equal to x initial plus VIXT plus 1/2 a sub x t squared. So here, x final, we're looking for that. X initial, 0. VIX, 83.9 times time of 14.64 seconds plus 0, because a sub x is 0. So my x final is equal to 83.9, right, times 14.64 seconds, and I get something like 1,228.3. So 1,228.3 meters. It's almost like 3/4 of a mile this thing traveled. That's far out. All right. What about part C? What about part C? At the instant just before projectile hits the point P, find the horizontal and vertical component of its velocity. I think we know how to do that because we already did it. So exactly right before it hits the ground at point P, we know it's going to have, so for part C, it's going to have the final velocity. Right? So here, at point P, right, this is our V final at point P. So we know this will have its x component. So this will have VFX, and we'll also have VFY. Oh my God, how did I look at that speed bump right there? How did that happen? So V, right, F, Y at point P. We already know what the VFX is at any time, right? Which is exactly same as your VIX, right? It doesn't change. And that is 83.9 meters per second because it doesn't change at any time at all. No matter what time it is, no matter where it is along this trajectory, my x velocity will always be 83.9 meters per second because it doesn't have any acceleration at all. However, my VFY will change depending on what time it is because it depends on gravity as well, right? So VIY plus a sub y t is how we calculate the VFY at point P. We know the time at point P, which is 14.64, right? So we know a sub y is negative 9.8 meters per second squared. We know VIY, which is 63.2 meters per second. We know t at point P is t total, which is 14.64 seconds. I'm looking for VFY at point P. So here, 63.2 minus 9.8 times 14.64 seconds. So, what is that, John? So here I have 63.2 minus 9.8 times 14.64, right? And it looks like I have negative 80.272 meters per second y hat. So that's my VFY at point P. That means my VF at point P is equal to 83.9 x hat minus 80.2, let's make it 80.3 y hat meters per second. So these are my components. So here's my velocity at point P in component form. Booyah. Now let's take a look at the magnitude of that velocity. Well, we know how to do that. So part D, the magnitude of that velocity is just simply that, which is something that we already know how to do, which is VFX squared plus VFY squared, right? So we already know how to do that. That is just the Pythagorean theorem of 83.9 squared plus 80.3 squared. Now, I know somebody's going to, why didn't you put negative 80.3? If I put negative in there and square it, I'm going to get positive anyway. I know so many students put negative in there, get themselves in trouble because they get something a lot smaller than either of these, right? Because they didn't put the negative in the parenthesis. So please be careful with that negative. So here, if I want to do this all at once, right, I get 83.9 squared plus 80.3 squared, right? And then when I square root that sucker, I get something like 116.1 meters per second for my magnitude of my velocity at point P. And then for part E, they want us to figure out this angle theta P. So for part E, they want us to figure out the angle at point P, and that is simply tan inverse of, right, VFY at point P over VFX. So my theta P is equal to tan inverse of negative 80.3 over 83.9. So my theta P is equal to, okay, tan inverse of negative 80.3 divided by 83.9. And I get negative 43.7 degrees. Therefore, if you want, you could write down your final velocity at point P in polar form by saying 116.1 meters per second, comma, theta P is equal to negative 43.7 degrees as your polar form for final velocity. Now, if you want to challenge yourself, this is what I did last year my honor students, because they had to know how to do this in order to solve for their lab, right? So what I told them to do was, I told them to try what is the position when t is equal to, when t is equal to 8.0 seconds. That means I want to know what your y at 8 seconds is, and I want to know what your x at 8 seconds is. Okay. Then I also asked, what is the VF, right? What is the VF in component form when t is equal to 8 seconds? So I wanted to find V, or I should have said VFY at 8 seconds, and then VFX at 8 seconds. Then find the magnitude of your VF at 8 seconds and theta at 8 seconds. So basically, like you're looking for same thing what you did for at point P, but you're just using 8 seconds instead of 14 point something else. You know, this can get a little tricky, but it's really not that bad. You're looking for Y final, right? You're looking for Y final at 8 seconds. So you keep your Y initial to be 125. You know your DIY. For time, you plug in 8. You know? All right. So 10:52. So any questions? Oh, I will stop the recording here. And then I'm going